Hello my lovelies, it's Susanna, and today I want to show you how to solve linear equations step by step. We're going to take a look at these two examples together, so let's start with the first one. This is our equation. We have our equal sign here. We have something on the left side of the equation, and we have something on the right side of the equation. And our goal is to solve this equation for x. So we want to find a number at the end so that if we insert this number for our x, then this equation is true. So we are going to do some steps. We have to take a look at what we're allowed to do, but at the very end, we want to have something like x equals and then a number, let's say 5. I don't know yet, but just as an example, we need x by itself on one side of the equation and a number on the other side of the equation. This is the goal. The question is, how can I get there? Well, you can think of an equation as a scale that is balanced. You have something on the left side of the scale and you have something on the right side of the scale, and your scale is balanced. What are you allowed to do with a scale so that it stays balanced? You are allowed, if you add, for example, 2 on the left side, then you know that you have to do that on the other side as well so that the scale stays balanced. Okay, so adding things is okay if we do it on both sides. Or taking things away is okay, but only if you do it on both sides. And that is the same thing with an equation. We are allowed to do something on the left side if we do exactly the same on the right side. And the things we are allowed to do are, we're allowed to add something on both sides of the equation. We are allowed to subtract something on both sides. We are allowed to multiply by something and to divide by something. Okay, so at the very beginning, always check where your x is. We have x only in this one spot here in our example. And we know that we want to solve for x. So at the very end, we want to have x equals something here. So we want to solve for our green x, which means that we now know that we have to get rid of this part here and we have to get rid of this part here so that x is really by itself on this side. Okay, so how can we get rid of the plus 1 here? We have to do the opposite. Here it says plus 1. We can get rid of it by subtracting 1. So I'm going to write what I'm going to do down here in this line, but we know we have to do everything that we do on the left side also on the right side, so we're going to subtract 1 here as well. So that we do something here and we're going to do something here. Okay, let's do it. So we have 3x here. They stay the same. We don't do anything with them. But here we had plus 1 minus 1 equals 0. So it just cancels out. And on the other side, we have 7 minus 1, which equals 6. This is our equation now. We still want to solve for x, so always highlight your x so that you know this has to stay on this side, but everything else needs to go. So we have 3 times x here. How can we get rid of this times 3? By doing the opposite. So instead of times 3, we're going to divide by 3. So we want to divide by 3, but we know we have to do everything on both sides. So also here we have to divide by 3 then as well. Okay, so dividing by 3 means that this cancels out here and only x is left. And here we have 6 over 3, which equals 2. And we solved for x. We are done. We found our solution to this equation here. And if you want to know that you made everything correctly, you can always check your result at the end by taking your number and inserting it for your x here, and then check if this equation is true. So let's do that. We have 3 times x, so 3 times, and for our x we're going to insert 2, and then we have the plus 1. Let's calculate this and let's see if that's the same thing that we have on the right side. So 3 times 2 equals 6, plus 1 equals 7, and this is what we have on the right side. So yes, this solution here is correct, and we solved our first linear equation. Let's take a look at our second example here. Same rules apply. First of all, we're going to check where our x is. We have an x here, and this time we have an other x here on the other side. But we know we are allowed to add things, subtract them, multiply, and divide. So my first thing would be this time to bring all x parts together. We didn't need that in the first example because we only had one x in one spot, but this time we have an x here, we have an x here. I want to combine the x's because we know that at the very end we are only allowed to have x on one side of the equation. So we know that either this part with x needs to go on this side, or this part with the x needs to go to the other side. It's your choice. You can make whatever you want, but I just prefer right now to take the 12x and to put them to the other side. So we have plus 12x. If I want to move them, I have to do the opposite. So I have to subtract the 12x so that they're going to disappear here. But we know we have to do the same thing on the other side, so we have to subtract 12x here as well. And always write your numbers below numbers and x parts below x parts. That's easier, so that I have the x parts here together. Okay, let's calculate this. 9x minus 12x equals negative 3x. Then I have the minus 21, and on the other side I have the negative 6, and here plus 12x minus 12x just vanishes, so it's not here anymore. Okay, so this is our equation now. Always check where your x is. We only have x now in this one spot, which is great, because then we know that on this side of the equation we have to get rid of this part and we have to get rid of this part so that our x will be by itself on this side. Okay, so we start with this part because always start with plus and minus movements, and we can get rid of the negative 21 by adding 21 on this side and by adding 21 on the other side. What do we get then? Here we have the negative 3x, they just stay. Negative 21 plus 21 cancels out, and on the other side negative 6 plus 21, you can also switch it, so 21 minus 6 if that is easier for you, which equals 15. Okay, we check where our x is. It is here, so we know we have to get rid of the negative 3 here. How can we do that? How is the negative 3 connected to the x? By a multiplication symbol. So it's negative 3 times x, and we have to get rid of this connection. So instead of multiplying, we just divide both sides of the equation by this -3, so that this will be gone here, but we also have to do it on this side. Okay, here the -3 cancels out and only the x is left, which is great. And here 15 over -3 equals -5, and we found our solution for our x. We can also check this solution, so if you feel like, I don't know if I made everything correctly, just take your solution, the -5, and insert it into your original equation for every x that you can find. So on the left side, if we start here, we have 9 times. For the x, I'm going to insert -5. I just have to write it in parentheses because I multiply here. And then minus 21. Let's calculate this first. 9 times -5 equals -45, and then subtract 21. So in total we get -66 on the left side, and we have to get the same result on the right side. So let's pray. We have -6 there, plus 12 times, and for my x, I'm going to insert my solution, so my -5. Let's see what we get here. We have the -6. Here, 12 times -5 equals -60. So in total, we get -66. We also got this on the left side, so both sides are the same, and this is the correct answer. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of our next videos. Take care!